What's poppin', math scholars? It's a gloomy Tuesday, and who is excited for math? Yeah. Okay, are we ready for our joke of the day? What did the... What? Wait, what?
Hear about?
Oh, did you hear about the rancher that had 48 cows?
No.
He had 50 after he rounded up.
I feel like you messed up a tiny bit. It's okay. Well, we're doing 1-9. This is the last section of the chapter, so it was a long journey through chapter 1. It'll be nice to be done. Our test is coming Friday, so hope to see you at a study party. Oh, gosh, we're going to need our graphing calculator today because we're going to be learning how to graph inequalities in the calculators. I just skipped like 100 slides. Basically, we're going to graph a parabola and then talk about where we would shade, above or below. First things first, we do need to review our inequality symbols. This is a less than symbol. This is a greater than symbol. And when using these symbols, you graph with dotted lines. This is the less than or equal to symbol. This is a greater than or equal to symbol. And when graphing with those, you use solid lines. So for this particular problem, when we graph this parabola, we're going to be using a what? Solid or dotted line? Dotted line, yeah. Alright, hello people in the video. We did talk about how Desmos.com graphs these so easily. I'll go ahead and show you what we did in Desmos. Did I close it?
No, it's right there. Oh yeah, you recently closed it.
Too many windows. Oh, because I recently closed it, but we talked about, there is, how easily it is to graph. And I know all the students were in here like, wow, if Desmos is so great and is so easily graphed, and you can see that dotted line, and you can see where the shading's at, why can't we use Desmos? Well, we can't use Desmos on the ACT, so that's why we kind of had to learn how to use the handhelds. Keeping my fingers crossed that in the next 10 years, Desmos comes out with a handheld calculator. It would be awesome. So, unfortunately today, we're going to be using our TI-84s. I went ahead and typed in the x squared plus 3x plus 7 part of it. But what is cool about these calculators, especially the newer ones, I'm not sure if the older ones will do this, I don't think the 83s will, you can arrow over and change your line type. So I can probably change my line to a dotted line, and I can probably change my line to being shaded below. So I believe I click enter when I get here. Yeah. So I'm going to go ahead and click enter. This is where you can change it from blue to a different color. And then you can also change by arrowing over where the shading's at. So I want it to be a dotted line, but I want it to be shaded below. I might only get to do the shade below. I might not be able to do the dotted line. So it might be up to your own brain power to figure out dotted line. I'm okay with my selection now, so I'm going to click OK. And let's see what we see. So there's my parabola, and it's shaded below. Isn't that cool?
This looks like the one on Desmos.
So I did, yeah, blue and shaded below. So if you want me to see that setting again, it's kind of blue, and I changed that straight line to a shade below line. And so now to transfer it to my paper, I would just do the best I can, just transferring that knowledge onto this paper. And I have to remember to use that dotted line, of course. So, dot, there's my parabola. And I'm shading below because of the less than thing. Now, a good way to check, I always like to say, well, let's check our work. What's a way we can check our work? We can do a test point. I always try to test 0, 0. So this is the coordinate 0, 0. It has an x coordinate of 0. It has a y coordinate of 0. Since it's living in this shaded solution region, it better make this inequality true. So let's try it. If I put a 0 in for y, and I put a 0 in for x, would this make a true statement? Well, because that is 0, of course. This side would be equal to 7. Is 0 less than 7? Yeah. So 0, 0 should be living in that solution region. Okay. So any questions on that? All right, we're going to try another one in our graphing calculator. Let's think about, with our brains, where the shading would be for this one. So it's y is greater than x squared plus 3x minus 4. Do we use a solid or dotted line? And do you think we would shade above or below our parabola? Y is greater than above, shade above. But we'll do the test point thing to kind of verify our result before we walk away. All right. So here's my formula. Move it over so you can see both. We're going to be shading above. So I'm going to go over and change my shade below to a shade above type of situation. So that would be like the upper half being shaded. I'll find it. That'll be this one. Okay, it's shading up. Go down, hit OK. And now my equation, got an arrow over towards my equation, is x squared plus 3x minus 4. It's a slightly different equation. Oh, I thought I was going to type over that. It's easier for me to go to the computer to type. 1 second. Alright, so I'm going to pause the video to help people out that are having issues, but it should be a dotted line, dotted boundary line, and shaded up above, which should be kind of like inside the parabola. Alright, hello people in the video. Now that everyone's got this graph, let's talk about a test point. I like to test 0, 0. Is 0, 0 living in the shaded region or on the outside of the shaded region? In the shaded region. So we want to verify that 0, 0, if I would plug it in the equation, would make this equation a true statement, since it's living in the solution zone. So put a 0 in for y, put a 0 in for x, and let's see if we're left with a true or false statement. So is 0 greater than, all that stuff would calculate out to -4. So is 0 greater than -4? Yeah. And that means 0 should be living in the solution region. So we did this one correctly. Does that make sense?
Yeah, that makes sense.
0 is bigger than -4? Okay. It's alright. Alright, let's graph 2 at one time. So this is called a system of inequalities. You're going to graph 2 at one time, and the overall solution region will be where the shadings overlap. So you like shade 1 in pink, shade 1 in blue. The overall solution is where pink and blue both live. Have you done stuff like this before? In the past? In your past life? Your past math life? I'm going to move it over a bit. Yeah, if you have a black and white calculator, you're not going to have 2 colors, but it's okay. Yeah, you put them both in at one time. So like this first one, it's y is less than or equal to. So is that shaded above or below? Below. So we want our first one to be shade below. So I'm going to select shade below. I'm just going to walk to my computer to do this, okay?
I learn new things about my calculator every single day.
I know, it's good.
I didn't know this.
So that's shade below. So, okay, for my first one, I'm going to shade below the equation negative x squared plus 4. That's my blue line. Now my red line is that y is greater. So my red line is going to be shade above. That'll be fun. I make this one a shade above. And they're both going to graph at once. This is going to be so cool.
What?
X squared minus 2x minus 3. So I'll leave that up there so you can see how I've inputted my equation. The first one was shade below with a dotted line. The second one, or sorry, solid line. This will be a solid line, shade below. This will be a dotted line, shade above. One will be an upside down parabola, one will be a right side up parabola. Let's do our best job at sketching it. Is it cool? I haven't seen it yet, I'm excited. That's the shade below. This is the shade above. So you can see where both the shadings live. That's your solution region where both shadings are. Isn't that sweet? Alright, so I'm going to do my best job sketching this. My sketch will not be perfect. Disclaimer, my sketch will not be perfect. Hey, is 0, 0 living in the solution region though?
Yeah.
Sure is. So just keep note of that. We're not going to take the time to check it. So here's my first one. My first one was solid line. My second one's a dotted line, boundary. And my solution region was where they live in between. This is not a perfect graph. I would probably, if I was taking a test, take a little more time to sketch that out accurately. But there's your concept. Oh, really? Great. So you learned it already in geometry. What a good day.
I didn't know. I didn't like.
All right. Hello. We are going to talk about the 4 steps to using the test point method to graph on a 2-dimensional number line. All day today. One-dimensional number line. All day today we've been graphing on a coordinate plane with an x and a y axis. That's 2-dimensional. One-dimensional would be just a one-way number line. So that's where we're headed next. But I told my students don't necessarily write all the steps down. I feel like that would take way too long. After we do a couple problems, I think you'll understand the steps. We're going to move all the terms to one side. We're going to use factoring to get our solutions. And then those solutions are going to be your points that you will graph. They're called breaking points. You will use test points on the number line to figure out where to shade. This will make a lot more sense when we try one. So this is what a typical problem would look like. You'd be graphing your answer on a 1-dimensional number line. instead of the coordinate plane. So you can't graph this in the calculator, unfortunately. You're basically going to use factoring to figure out your solutions that you'll end up graphing. So these will be factorable. We're going to be nice to you and give you factorable problems. Let's just use the old-fashioned factor technique. What numbers multiply to a positive 7 that would add up to negative 8?
8 and negative 1.
How about negative 7 and negative 1? Beware of the double negative. Negative 7 and negative 1 would multiply to positive 7 and add up to negative 8. So that would make my solutions positive 7 and positive 1. Now your solutions are the guys you're going to graph on the number line. If your symbols are less than or greater than symbols, you will use an open dot when you go to graph the points. If they're less than or equal to and greater than or equal to, you'll use solids. I feel like we've done that since 8th grade math. So we're going to go to positive 7, or we're going to go to positive 1, and we're going to do open dots there. Positive 7 and positive 1, open dots.
We've done these before.
Yeah, you've graphed on number lines before, but never quite in this manner. We have to figure out what zones we're going to shade. So basically we have 3 zones. Zone 1 would be this region down here. Zone 2 would be this region right in here. And zone 3 would be this region up here. Normally you're either shading zone 1 and 3, or you're shading zone 2. Normally that's how these work, but we'll test points in each zone. Let's start by testing a point in zone 1. Can you pick a point that lives in zone 1? Why test negative 1 if you could test 0? Let's just test 0. Why square a negative number? Because think you're putting it in this equation. Why square a negative 1 and maybe forget your parentheses when you can square a 0? So we're going to go ahead and test 0. This is me testing 0. So is 0 squared minus 8 times 0 plus 7 going to be greater than 0? 7 greater than 0? This stuff's all 0. So is 7 greater than 0? Yes, sure is. So I'm definitely going to shade zone 1. All right, let's test a point that lives in zone 2. Can you guys think of someone that lives in zone 2? Any of these numbers in here? How about 4? 2. 2 would work, 4 would work, doesn't matter. So let's test 4. Is 4 squared minus 8 times 4 plus 7 going to be greater than 0? Might need a calculator for this one, but it's 16 minus 32 plus 7. So that would be a no. So we're not going to shade zone 2. And then we need to test a point in zone 3. You pick a number that lives in zone 3? 9? Okay. Let's test the number 9. Is 9 squared minus 8 times 9 plus 7 will be greater than 0? So 81 minus 72 plus 7. Yeah, you can use your calculator, you can use some mental math, but that's going to be a yes. So since that zone's true, that's real graph. So it's kind of strange, but did you follow up if testing all of our numbers in all our different locations? And again, if you're confused on how to get these 2 dots to begin with, and you're just using factoring and solving. Better pause the video. All right, we'll try this one. First of all, before you use factoring to solve anything, you always have to be set equal to 0. Just like yesterday, using the quadratic formula, you got to be set equal to 0. So I'm going to start by subtracting the 6 over. That would be x squared plus x minus 6 is less than or equal to 0. And now we're ready to rock and roll. Let's use some factoring. What numbers multiply to negative 6 that add up to positive 1? I was thinking positive 3, negative 2. Very good. That's a positive 3. It's just not writing that well for me today. That makes my solutions a negative 3 and a positive 2. So when I go there, since I have a less than or equal to sign, I'm going to be making solid dots. So we have a solid dot at negative 3, and we have a solid dot up at 2. We need to test somebody in each of the zones. So zone 1 would be down here, zone 2 would be in between here, and zone 3 would be up at the top. If you guys want to test first. And I would do my test back into the original equation. So you guys want to test, I don't know, -6 maybe first? -6 is in zone 1. So when I test a negative, I use parentheses. Is -6 squared plus -6 less than or equal to 6? So is 36 plus -6 less than or equal to 6? No, because it would be 30. 30 is not less than or equal to 6. We're not going to shade zone 1. All right, let's test somebody in zone 2. 0. No! Don't test -1 when you can test 0. Always use 0 as a test point. 0 is so easy to calculate with. You'll get on my team soon. Team 0. I'm on Team 0. I'm going to make a t-shirt. Hashtag Team 0. But anyways, is 0 squared plus 0 less than or equal to 6? Yes. So we're going to shade the zone control in. Most likely that's going to be the only zone we're shading, but let's just finish it out and be complete with our work. How about we test the 5? Is 5 squared plus 5 less than or equal to 6?
30.
No way. Yeah, that's 30. So that's our answer. Our answer is the number line, by the way. This number line is your answer. All right. You ready to see if you can graduate? Let's give these kids a graduation problem. One of these number line problems today. Let me pause the video and find a good one. All right, people at home, we've arrived at our graduation problem. All the kids in here are going to try it by themselves. You can pause the video and try it by yourself. All right, it's time to see how our pathway to graduation is going. Did you guys get the 15 to the side with all the other numbers? Did you factor it using a -5 and a +3? That makes your solutions and the points that you'll be graphing a +5 and a -3. Now, I graphed them with an open dot because this was a greater than symbol. Just keep in mind that's the type of dots you want to use. We're ready for my test zones. I'm going to test them in the original function at the top. I'm actually going to start myself off with testing 0, because you know me, I'm on Team 0. So is 0 squared minus 2 times 0 going to be greater than 15? No. So this zone is not going to be shaded. You can just write no up there if you want. Then odds are we'll be shading the zone up here and the zone down here. It's just how these ones work. So maybe let's test 10 next. Is 10 squared minus 2 times 10 going to be greater than 15?
Yes.
So 100 minus 20. Yes. We're definitely going to shade the zone up here. So yes.
You can do the same thing on the other.
Yep. So let's test, I don't know, -7. Is -7 squared minus 2 times -6 greater than 15? It's harder math. It's 49 plus 14. 49 plus 14 will be a for sure yes. So I'm going to shade that zone. And this number line down here is my final. So how are we doing out there? Ask some questions. I feel like sometimes I ask if there's questions and there's no questions. Just ask questions if you have them. Any questions on that? How many people did graduate all by themselves? Perfect. All right. So your homework is right about here in the book. Maybe snap a picture of it. And this is your last homework in chapter 1. Yay! Chapter 1 is done. Awesome.